back to chapter 6, normal distribution. To convert x. Yeah, this is still normal. We will spend a lot of time under normal, probably this week and next week. So this is the convert, it is z x. This is the conversion formula. So whenever one is certain that the problem is about non-standard normal, all you have to do is to convert it to standard normal in order to use the table. So let's look at these examples, which I believe may be helpful.
And the standard deviation is still sigma, right?
Yes, it's still sigma. It hasn't changed yet. When it does, just kidding, I'll let you know. All right.
So you have to first determine whether it's standard normal or non-standard normal, correct? You have to determine first.
Yes, you have to. And how do we know whether it's a standard or non-standard normal?
If it's not normal, then it must be zero, non-standard deviation not equal to 1.
It is still normal, but we have standard normal and non-standard normal.
Non-standard is X. I'm confused on the criteria for that.
I think somebody knows it, yeah?
Isn't it that non-standard has X?
Come again?
Non-standard has X.
Non-standard is X. So what makes a given normal problem a non-standard? What is the difference between standard normal and non-standard normal?
Standard normal is mean of 0 and a standard deviation of 1, and everything else is non-normal.
Excellent. So let's read this problem. This is a practical application. It's something which occurs somewhere in the tri-state, Virginia, Maryland, and probably Washington. Somewhere there. When a taxi sank in Baltimore Inner Harbor, an investigation revealed that the safe passenger load for water taxi was 3,500. It was also noted that the mean weight of passengers was assumed to be 140. Assume a worst-case scenario in which all the passengers are adults. This could easily occur in a city that hosts convention in which people of the same gender often travel in groups. Assume that weight of men are normally distributed with mean 182.9, standard deviation 40.8. So looking at that problem, is it standard or non-standard normal? Why is it standard? Why is it non-standard? How do you know?
Because they say a mean weight of passenger was 140 pounds.
182.9.
It doesn't say that.
It's none because the mean, it says there that it's 140 pounds per passenger.
It doesn't say that.
It's assumed to be 140 pounds.
Are you in A or are we still in the question?
We're still in the question.
Can you tell me what page that is, by the way?
Oh, that would be page 293.
Thank you.
So what is this problem about?
Weight.
Of?
Men.
Excellent. It's about weight of men. It has a lot of information there that are to distract you. But you have to actually fish for the right information. So this problem is about weight of men. What is the mean of the men? What is the standard deviation?
40.8.
So is this a standard or non-standard normal? Why? What is the mean? Okay. So now we know that this is a non-standard normal because the mean is not 0. That's how you can tell, or the standard deviation is not 1.
You want to look for those two things off the
Before you even think of using these things, those things, excellent. Those things don't actually make sense. You'll be given a lot of information, but as a good statistician or a probabilist, you need to know what to take. So now that we've said that the mean is 182.9, is it 182.9? Standard deviation 40.8. Now we can go to question number 1. It reads, if one man is randomly selected, find the probability that he weighs less than 174. How will you translate that into probability terms, symbols? Find the probability that he weighs less than 174. We want to translate that statement to mathematical symbols.
So you're starting with the mean and then subtracting the...
Before we do that, we need to get a statement, and then
Are we using formula for that?
we'll be using the formula. P, P, what? YX, but not Z. That's not really, why are we using it? Why don't you use the Z here, but X? Because a non-standard normal. You just said that this is non-standard normal, right? And if it's a non-standard normal, you use the symbol, not the Z. Does that make sense? And we just translated less than 174 to that. Now what next? Come again? Yeah, I want the right name. What numbers are we putting? What are we trying to do? So what are we trying to do? Convert what? Convert to Z. You already know how it works. I just want to put the pieces together. Remember, no, you cannot take this X to the table. You need to convert that to Z. How do I convert this number to Z? Minus the mean divided by standard deviation. Subtract the mean. And what is the mean? 182.9 divided by 40.8. Please take out your calculators and compute this round to 2 decimal places. Go, 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 go. All right, I'll wait for you. Negative 0.2 218.
Yeah, I have 218.
So what should I write? 22. Why are we not writing the 218? Why do we want to round it to 2 decimal places? So that you can use the table. So understand why we're doing all these. Why did we start with X? Because it is non-standard. Why do we have to change to Z? So that we can use the table. Why are we rounding to 2 decimal places? Because on the table, everything is rounded to 2 decimal places. Awesome. If you're able to put these pieces together, normal distribution wouldn't be an issue. Great. All right, so to the table. Now, can we go to the table? Can we look up the table if there's not? Why? That's not why. Can we look up the table? Why? No. Can we look up the table?
Because now it's normal. Is it normal?
We have a Z, but that doesn't mean we should look up the table.
I don't think we're ready yet. You have to
What happened to statistics when you have a weekend? Lot of party and you forget statistics. Okay, a lot of homework. So if you do anyway, why do we have to? So why are you going to the table? If you don't know why you have to go to the table, why are you taking the table? Yeah, look at your notes. And let's understand why we can go. Yes? No. Once you get to the table, we do the separation. But why do we even have to go to the table?
To avoid the.
There's a reason. Because it is less than. That's why you go to the table. If this were to be greater than, most of you would have read the number and given me the answer right away. Now you're excellent. The rules. There are a lot of things to remember under normal distribution. So we are looking up the table because this is less than. Because if this had been greater than, there's no way you could have read this from the table. You remember those rules? We talked about that last time. Now I believe you are remembering. Awesome. Rule number one. All right, now give me the values now that we know that we can go to the table.
I don't even know how to use the table.
0.4129, which is about 41%, right? This is about 41%. So we have a 41% chance that whenever you select a man, the weight will be will be less than 174. Great. Any questions? Any concerns? This is the first example. That's why we're going through this. With time, I'll pick up the pace and I'll be moving with the speed of light and we'll not be wasting time on this. Let's look at number 2. With a load limit of 3,500, how many male passengers are allowed if we assume the mean to be? Are we on the same problem? 140. That's it. It's just a division. This is not probability question. 25, right? Yeah. To get that answer, divide 3,500 by 140. You get to know there were 25 people involved in this. Yes. That's right. Like, yeah. Now let's look at the next one. With a load of 3,500, how many male passengers are allowed if we use a new mean of 182.9? Yeah, so you round up because it must be discrete. 19. So we have 19 for this. Oh, that was C, right?
Yes.
And B is 25. Now, can we relate this to the problem?
I'm sorry, where'd you get the 19?
Yeah.
They divided 3,500 by 182.9. Can we relate these two information to what we just read? It must be practical. We're not just dealing with numbers.
There were 6 people too many.
That's it. Because that was the assumption years past that the average weight of men or passengers supposed to be 140. And if it's 140 and the capacity of a boat, a ship, whatever it is, an automobile on water is 3,500, under normal circumstances, using the 140 average, the average weight of 140, you're supposed to have 25 people. But it shifted. It wasn't so. The weight is now changed to 182. So the more people you put in, you had the danger of sinking the boat. And that's what was happening. A lot of boats were sinking.
So in some sense, your mean stays the same at 140 pounds. So even though you have people that weigh more, you have to put on less passengers.
Now we have moved from 140 to 182 point that. That is the assumption now.
Yeah, but technically that doesn't change, right? Because the load limit doesn't change, so you have to drop the number of passengers now because they weigh more.
Yes, that's what I wanted to say. So what were you waiting for?
Your mean still theoretically is 140 pounds, but now you got all these people that weigh more, so you got to put less people.
So theoretically, that's what it was, but now it has shifted. Excellent. So make sure you don't put 25. Otherwise, we risk sinking and getting to the other side. Great. That's a good one. So don't just do the numbers. Try to understand what is going on. Great. I like the last part. I think we've already answered it, but let's read and see whether we can connect. Why is it necessary to periodically review and revise the number of passengers that are allowed on board?
No, because the weight of them is what matters, it's not the number of people.
Excellent.
The mean can change.
The mean can change. And I think naturally men are supposed to be heavier than women, yeah? Oh, yes. You may see us slim, but we weigh a lot.
So obviously every
Yeah.
airline and every aircraft has a mean for
Each passenger.
particular aircraft.
Excellent.
The size, the engines, the weight of the aircraft.
Excellent. Together with the weight, apart from the carry-on load, the actual luggage.
Is there a variance? Is there always going to be a variance?
There is, but they compute that not the same as we do it here. That's done differently.
They incorporate.
Yeah, it's more of this, we'll call the variance, standard deviation, yeah. So there's a big study for the error, which they try to avoid all the time.
The arrow?
Error. The error. Yeah. Let's see if we can find, let's go back to this. Exercises 21 through 24. Let's read this and play around with that. Men's heights are normally distributed with 69.5 inches, and the standard deviation is 2.4. Women's heights are normally distributed with mean 63.8 and mean of 2.6. So are these standard normal or non-standard normal? How do I know? Because the means are not 0 and the standard deviations are not 1. So right away you know that there must be a conversion. And so which variable should we start with? X. So let's start with the first problem. Question 21. Find the percent of women meet... wait. I skipped something. The U.S. Navy. The Navy requires fighter pilots have heights between 62 and 78. If you don't fall within that height interval, they cannot recruit you. Find the percent of women meeting this requirement. So A.
62.
Before that, P. Remember, probability is the same as percentage and decimal. 62.
Bigger than that one. Would it be Z?
Why? Why Z? Well, somebody should help out. Why the Z? So it cannot be Z. Thank you. Thank you.
And then the other number, whatever it is, 78.
You see the interval, how the interval is written.
I don't understand. Where'd you get the 62? I'm reading A.
What do we do from here? Convert. And why should we convert? Excellent. Because without the Z, we can't go to the table. Awesome. So, how do we convert? How do we convert? If you say do each side, do what? No, what am I supposed to do? If you say do this first, like what am I supposed to do? how do I find the z for the 62? Yeah, do what? Go get it. Come on, we just did an example. Have you forgotten so soon? How are you going to do your homework? And she said one thing. I need more. Come again? What is that 62?
62 is.
No, what is that 69?
You subtract from the mean and divide the standard deviation.
Awesome.
What?
She wants to know that again.
Subtract from the mean and divide by the standard deviation.
That's how you change x to z. It doesn't change.
Oh, so you're just using the z equals x minus.
That's it, because we're changing x to z. That's what you said I should do, yeah? Yeah. And in changing, you subtract the mean and divide. Don't forget these things, please. All right, so what should I write? Great. All right, so what did she say? 62 minus 63.8. Now I'm going to go back again. Why are we not using 69.5? And what is this about? So you know why we're choosing that. Please connect. They are explaining everything step by step. You notice I'm not doing anything. And I will divide by 2.6. Less than or equal to, this is now z. Less than, you do the same thing there. Over 2.6. So far, so good? All right, now you know I can't do that. Or maybe I can, but I want you to try. Yeah, that's why you have to take 097 before you take this class. Negative 0.69. Thank you. Z. Come on.
Yeah, 53.46. So 53.
That's too big a number. Come again? Is that okay?
Yeah, 5.4. 5. And it would be 5.6.
So what should I write?
4.6.
Is it 4.6 exactly?
No, it's 4.61.
Oh, 4.61. Oh, okay. So like that. And why are we running to two decimal places again? Aha, now I feel good. What's next? How do we go to the table if you have an interval? Oh no, you have that. We did that last week. So please, if you've forgotten, go back. Just refresh it and tell me what to do. If you have an interval, how do you read it from the table? Subtract the biggest from the largest. So you first find the area for 5.69. What is that from the 5.46? And what is that from the table? 5.46. From the table, what is the area? Are you sure about that? 0.99999. It states that in the bottom, that anything above 3.5 should be 0.99999. It's on your table. Minus, now you want the probability or the area of this negative number. Point. 2,
2451.
like that.
Yes.
So now you can do the deduction. That will be point. And what is the meaning of that? So about 75% of the women populace will qualify for that position, the fighter pilot. All right, so the question is, are many women not qualified because they are too short or too tall?
Around 25%.
So what do you think? 75, is it good enough? Is it too small? Is it too big a number? Okay, so it's kind of subjective though. But 75 is big, it's bigger than 50. So at least we are considering about 3/3 of the women population, which is fair. Great, let's go to B. Find the percent of men meeting this height requirement. Same thing. So same thing means probability of 62. And what is next? How do I do that? This time we using, why are we using different numbers now? Excellent. Great. So we have Z 78 69.5 over 2.4. And calculator. Negative? Exactly. So what should I write? 3.00 less than Z, less than or equal to. Oh, okay, sorry. 3.54. So,
So, for the first one, 62 minus 69.5, right there. Like, you just do it as is. You can't switch it around.
no, don't switch it around. Yeah.
Okay.
Do it as it is. So from here, where do we go? Table. Which of them should we read first? The bigger number. So read that and give me some numbers. Point 0.9999 minus, what about negative 3.00? 0.0013. Any questions about how to get these numbers from the Z table? You okay? Okay. All right. So what is the difference between these? Yes?
For the second one,
Mm-hmm.
0.0013.
Uh-huh.
I understand. I would go down to,
Negative 3.0 under the 0.
oh, under the zero.
Yes.
Okay.
So it will be the first one.
Right, okay. Got it.
Great. And what is the difference, please? So about 99, almost 100% of men qualify for this. Like all men, if they want to. Great. You have, I think I need a question on, maybe I don't, maybe I do. I want a question on, all right, since I can't find what I want, why don't I come up with one? Now, what if Now, this is not coming from your textbook, but it's related to this problem. What if there is a group, that is question 3 out of whatever we're doing. What if there is a group who's required, before you can join the membership or be part of the group, your height must be greater than 70 inches. Just like basketball. If you are short as I am, the likelihood of being recruited by any team is 0.
Yeah, Isaiah Thomas, he's like 2'2".
He has the skills.
He does.
I'm not even a Boston fan, but anytime I look at him, I fall in love with Celtics. He's nice. I like him. Anyway, let's talk about that. So, assuming probably it's a basketball team, whatever it is, or it's a group of tall people, and the requirement is your height must be greater than 70 inches. So you go, they measure you, Francis, you don't qualify. Then I go home. And a person goes, cry a little bit, not a lot. And I go home. And another person goes like, hey, you qualify. Why don't you come right in? They pick you. Great. So if it's greater than, what do we do? Men. We're talking about men.
You still need to convert it to C.
Excellent. So how do I do that?
X minus the mean divided by the standard deviation.
Give me the numbers. I'll write it down for you. We're still using that problem. 70, 69.5 divided by 2.4. So I have P of Z greater than or equal to 0.20. Great. 208. Then to be 21. Don't lose some of these, otherwise you struggle on your homework. You do the right thing, and you will not get the right answer. So you'll be complaining, what is going on? What am I not doing right? Maybe you are not running rightly. Great. What do I do from here? She says you can't go to the table. Why don't you challenge her? Now we are keeping with rules. This must be less than before you go to the table. How do I make it less than? You flip the sign. Excellent. So now this is what you are going to read. That is why I was asking these, call it unnecessary questions, but just to guide you and to help you understand whatever it is we're talking about under this chapter. And I think you're going to get a certain number over there, right, from your table. Everybody knows how to read a table, so no sweat. Now, like the ordinary algebra, where we do subtraction and addition, multiplication and division, kind of the opposite of stuff. We want to look at the opposite of what we have done here. So we call it inverse normal. Well, not necessarily a third type. I wouldn't call it like that. It still falls under the standard and non-standard, but this time it's a subcategory. Till now, yes. Yes. So you can also read this.
Is that 1 minus the whole P minus Z?
Yeah, it's 1 minus PZ less than 0.21. You will look up the table and read 0.21. And then whatever you get from the table, you deduct from 1. Yes, we did that. And we will be revisiting that maybe today. I don't know. So far, this is what I've taught you. It's been a lengthy discussion, but we can summarize this with this simple statement. That You may be given a non-standard normal. And what do? You convert to z. And after you get a z, what do? You go to the table and get a probability, right? Yeah. That's all we've said so far from last week till now. Yeah, it's a lot under this simple statement. This time, this is what we want to do. We want to start from probability to z to x.
I don't even understand that process. Serious.
Because it's practical. It's good for construction firms and the designers. Come again?
Why are you always trying to confuse us?
It's not me.
No, he just has so many options, so many options.
Yes, we will start with the table probability and then we work our way back to the x.
So we're gonna start with one of these like decimals?
We will get there. We will start, yeah. We will start with the decimals and then we use the table to get the z and then the z to get the x. So that will be called inverse normal. Inverse normal involves probability, and you know probability also, like another name for probability is percentage, right? To z, and from z to x. Now this x is given by a formula, which is mean plus the standard deviation times z. Or simply put, this is equal to mu plus times z. The Lord has already had mercy on us. So x is equal to the mean plus the product of the standard deviation and z.
That's standard deviation times z.
Yes, that's standard deviation times z. But the good thing is, or the good news is, the mean and the standard deviation will always be given to you, just as we've already seen. Whenever you are told that there is a normal distribution, mean standard deviation is given to you. Yes. Mean plus standard deviation times z. Times z. And that is what I've simplified in the simples. Yeah, that's times standard deviation. I think you like this better. You have mean, you have standard deviation. The only thing left is z. So I'm going to show you how to find the z. That is what we call the inverse normal. Because inverse normal says probability or the percentage will be given to you. And then you will use that percentage to find the z. Once you get z, substitute that into this formula together with the numerical values for these two parameters and compute x. We're solving for x. Solving for x means inverse normal.
Is that gonna be on the test? Of course it
Of course it is.
Why are we always looking for X?
Because our life is full of x's.
Is x the probability?
No, x is not the probability. X is the normal thing. And don't worry, with time, once we begin to solve problems, you get to understand the practical approach of that. Because life is full of Let's continue. It's full of unknowns. And you know in math, if it's unknown, you call it x. Yeah? You learn that from...
They're not unknown.
All right. You know, and now I know you want to read a lot of meaning into x's, which is good. We can talk about that. All right. So let's do this. Take your tables. If you don't have one, please sit next to somebody who has one. This, yes, we're going to do backwards. This is your table. And since we are going to use the probability to find the z, and on your table, you have the probability body here. What you'll be doing is you'll be moving from here to the outside. So far, this is what you've been doing. We've been moving from here to there. Now we're moving from here, there. Does that make sense? Yeah. Nope. Great. It's like you have to ask yourself, why does a car have a reverse? In life, everything that can go forward can go backwards. That's a fact. Everything. Say you haven't seen one before.
Except
Life?
life? Or time?
Time.
The time goes back when it's changed.
That is man-made. Until I came to America, nothing of that existed in my life.
Yep.
Oh, we move it forward one bit. Oh, we're taking it back. Man, men can control time. Awesome. That's nice. How do I want that? No. All right, so this is what we're talking about. We're going to have the probability. We use the probability to go backwards. So assuming I give you this value. Oh, I don't have a table. I have one. 0.9265. If this value is given to you and you are asked to find z, what will be z?
1.45.
So she says it's 1.45. How did you get that? So what you want to do is to look for this number. Is it good? Yes, but it is not hard. Why? It's ordered. Everything is ordered, so it's not hard. You haven't paid attention to the table. It starts from 5, 6, 7, 8, and 9. You see that now? So you notice that 0.965 is 1.4 and 0.05. That is why we say it's 1.45 Z. More examples.
It's hard to look for it. It's gonna take time. Come on, it's a second. Yeah, when you're on the test, I'll tell you.
All right. Assuming you have 85.54% and you want to find Z, what do you have to do first? Divide by 100. We change that to a decimal, which becomes 0.8554. Now you want the Z.
Which is 1.06.
1.06. Anybody here who is confused? Let us help you. Otherwise, we cannot continue. So the first thing you have to do before I can even help you, Jeff, is to locate this number within that table. 0.855, yeah, it's the same thing. 0.8554. Find that number first, and I can help you from there. 8554. It's in there. The numbers are ordered. Everybody okay here? You need help? Oh, you got it? Have you found the number? Yes. No, look for it. It's there. No, don't point it from the top, from the body. What are we looking for?
Okay, so I see that there.
Good. So now you want the Z value that gives you that.
Yep, I see
1.0 and then the top. Look at the top of that. It's 6. Because initially, this is what you were doing. If I were to ask you, find the probability of z less than 1.06, you will go to the table and tell me it's 0.855 that. This time, 8554. This time, we take this out. And we are saying that this is given. Can you find that value which gave you this? That's what we're doing, the reverse.
What was the 9265 first? Was that the same? It's different thing?
Oh, it's a different thing. I was just giving you different percentages, yes. Homework? Yeah, I will fix the homework in your absence. Oh, you need help?
Yeah, we need help. Because this is a good point to
No, I want to make sure everybody understands this first. I can talk about homework on Thursday. But now, this is very, very important because if you don't get this, we can't even continue, yes.
So, on the next test, in the first section, we're going to be able to have the table and everything.
Everything.
Alright, cool.
But the good thing is the next test,
That's the one thing about this class. Doesn't matter all the tables and formulas you have. It doesn't help you at all.
I know.
it does help you.
No, you know, if you don't understand,
Yes.
it doesn't matter. You have all the information.
So curious. It's a good thing.
Let's try to understand that.
Great. Do you all get it?
Yes.
Yes.
Why do you come up with 1.06?
Because
Because I found the number. It's
point here, 8585855. This one.
yeah.
So it's 1.0. So it's 1.0, and then you add the 6 to it.
Oh, okay.
Now, how do you know whether to write less than or greater than?
Here,
Yeah.
you will not be told. We are not even using. I'm not writing this. What we're learning now is how to move from this to that.
So you're just getting a value for z.
Excellent. Once you understand that, that is when I'll bring in the less than or greater than. So let's start with just the simple ones. What about if you have this 0.9750?
It is
1.96. 1.96. Excellent. That's good. The next thing probably you should be asking yourself is, what if that probability value is not on the table?
no. Come on. See what I'm saying? Skip that question.
What if that number is not on the table?
We invented it. We got the two closest one. And
No, we're not even talking about, we're talking about the probability. For example, if I ask you to find 0.7784,
so what we do, we get the 7785 and the 7786, and we put it together and get the middle.
Didn't you show us a way to find that value?
that kind of that.
You take it, but
It's kind of
the
that.
higher and lower value.
Come again?
Take the higher and lower value.
So we're looking for 0.7784. This is not on the table.
Do you average the two closest numbers? See what we do, 7784.
So-
It should be 0.7 and 0.65.
Since this guy is not on the table, you will look for two numbers between which this guy will fall. So what are the two numbers on your table? Using your own discretion. 0.764. And what is the other one?
77794.
94. So you see, this number is not on the table, but we are able to determine that it will be between these two numbers on your table. How do we continue from here? Simple. Find the z value of this smaller number. What will be the z value?
0.7.6.
0.76, and this will be 77. 0.77. You add them and divide by 2. You average. Come again. No, I did not round it up. Oh. What is that? Is it 775? No, 765. That was right. Or maybe not. That becomes the z. So it's possible. Our last example, I think I have time for my last example. What if we happen to have 0.02? That's not true. Yes. 0.02.
It's 508. I don't know. No. Oh, in there?
0.02. That's the same as 2%. No, that's a lie. Excellent. You have 2 tables. You don't have 1. Ah. So, but you are looking for the 002. Oh, no. Don't give me that yet. I'm just interested. Since this guy is not on the table, I want 2 numbers. 210.
Mine is 2.01.
0.0021. I have just 1 0. So 0.00, 2 zeros will be way off.
0021, 0021, 0020.
No. Now you are way off track, so to stop disturbing the class. Point 0.0186.3. Zero 237. Awesome. 8. So these are the numbers. That is the interval that will contain 0.02. No, this is not statistical. This is 093. How to put decimals in order. They taught you that.
I don't see 002.
There's also a 0.0197.
0.1. Oh, then this is too small.
And then there's a 0.
0.0197.
And the one is next to it, 0.0202.
Ah, that is much more closer. So you notice it's not me. I cannot even point it out to you. You have to open your eagle eyes. Searching. Where can I find these numbers? If I cannot find it, between which 2 numbers will this number fall? And then you can continue from there. We will continue with this exercise or this work on Thursday.